Okay, Bismillahirrahmanirrahim. Assalamualaikum and good day. Salam sejahtera semua. Okay, so hari ni we will going to learn a new subtopics again. Okay, which is rate of change. Okay, at a specific point. Okay, so the rate of change of a function at a point is the gradient of the tangent to the curve at that point. Okay, so basically we have, let's say, a function. Okay, it is graphed in this way, and then we will want to measure the rate. Let's say we want to measure the rate of change, okay, at a point. Okay, so what we have to do is, let's say this is the point. Okay, so we have to draw a tangent. Okay, and then we have to find the gradient of tangent, okay, of tangent at the point. Okay, so we see the example here. Okay, so given y equal to function of x equal to 3x squared plus 2. Okay, and then we have to estimate the rate of change of y at x equal to 3, okay, by considering the intervals below. Okay, so we have to consider figure 10.8. Okay. Okay, so here, okay, now let A be the point 3 and 29. Okay, so here A is the point for x is 3, y is 29, and then okay, B is the point for 4 and 50. So when x is 4, y is 50, this is the point B. Okay, so okay, so for the first question, which is interval 3, 4, right? Okay, it's interval 3, 4. So change in y and change in x. Okay, so where is the change? Okay, so we note change with the symbol, okay, y and then change in x. So this is the change of delta x, and then this is the change for delta y. Okay, so we have to calculate. Okay, yeah, when y is 4, okay, for y when x is 4 is equal to 50. Okay, we just input, okay, 3x squared, okay, 3 4 squared plus 2 is 50. Okay, and then 3 squared, okay, 927 plus 2 is 29. Okay, so that's how we get this one. Okay, so 50 minus 29, and then divide by 4 minus 3. Okay, so we get the equation answer as 21. Okay, so the rate of change at A is approximately 21. Okay, then for next interval, which is 3 and 3, 1. Okay, 3 and 3, 1. Okay, so this one just maintain. So here will be y3, and then this one will be y3.1. So this is what we calculated. So minus 29. Okay, we get 18.3 as the equation. Okay, and then now for next one we will go smaller. Okay, which is interval is 3 and 3.01. Okay, so notice here that the unit here is 1. Okay, the difference here is 1. And then the difference for B, interval B, is 0.1. Okay, the difference for unit, this is 0.01. So it's getting smaller. Okay, so when for B, interval B, okay, you can see that the answer is 18.3. Okay, which is more accurate estimate of the rate of change at A. Okay, it's smaller. Okay, and then when interval C, which is 3.01, okay, we just put here y 3.01. Okay, we get 29.1803. Okay, and then minus 29. So lastly we get 18.03, which is more smaller than previous interval in B. Okay, so we can say that, okay, if x increase by 1 unit, okay, then y increases by approximately 18 units. Okay, that is for particular function. Okay, the function that we will discuss in the example. Okay, so this is more detail, more about the discussion. Okay, by taking smaller and smaller intervals, okay, better and better estimates of the rate of change of the function, okay, at S3 can be obtained. Okay, so we introduce a small change or increment of x, okay, denoted by delta x. Okay, now we have to consider the interval 3 and then 3 plus delta x. Okay, and then we tend to let the delta x equal to 0. Okay, okay, next is example 10.5. Okay, so we have to find the rate of change of y, okay, for this function at x equal to 3. And then we have to consider by using the delta x here. Okay, okay, so let's do. Okay, so we have the function given here is y equal to x squared plus 2. Okay, and then we have to find the rate of change. Let's say we have to find y, or we can say dy over dx at x equal to 3. Okay, and then we have to use the interval 3 plus delta x. Okay, so as usual, okay, so let me do this first. Okay, so to find the dy dx, okay, or y prime, we have to do the, or even this. Okay, so y3 plus delta x minus y3. Okay, and then here 3 plus delta x, okay, minus 3. Okay, so we have to find, okay, now we can cancel out the 3. Okay, now we have to find out y 3 plus delta x. Okay, so we just convert this one into this one, into x. Okay, so it will be 3 plus delta x, 3 plus delta x. Okay, and then plus 2. So here we have 3. Okay, okay, 3, 9. Okay, 9 plus 6 delta x. Okay, plus delta x squared plus 2. So we have 27 plus 18 delta x plus plus what? Plus 3 delta squared plus 2. Okay, so we have 3 to the power of 2 plus 18 plus 29. Okay, so now we are going to put into the equation here. Okay, so we just put delta y over delta x. Okay, is equal to okay 3 delta x squared plus 18 x plus 29. Okay, this is for that one, and then for yx or y3. Okay, so can do y3 here. Okay, so if y3, you just put x as 3 squared plus 2. So 18, 9, 27, so 29. Okay, so we just minus 29, and then this one is delta x here. Okay, and so we can cancel out 29, 29. Okay, we can exclude the factorize the delta x outside. Okay, so delta x here 3 delta x plus 18. Okay, and then this one is delta x, so we can cancel out here and here. So what left is equal to 3 delta x plus 80. Okay, so we have to let delta x equal to 0. Okay, therefore rate of change of y when x equal to 3. Okay, so delta x for the function. Okay, we can write down the function here. 18 is equal to 18. Okay, So that is the rate of change, which is 18. Okay, the rate of change of y. When x equal to 3 is 18. Okay, then the rate of change at a general point. Okay, so now, okay, we are going to develop a general terminology, okay, for the method. So average of change of y, as usual, change in y divided by change in x. Okay, so we can say delta y to delta x. Okay, here. Okay. Then when we are using the delta x, okay, we have to write this in the end. Okay. Okay, now we see next example. Oh, here. Okay, so this one is, okay, so delta y is this one. Okay, delta x is this one. Okay. So delta x is by x plus delta x minus x. Okay, so cancel. What left is only delta x. Okay, so example 10.6. Okay, we have to find the rate of change of y. Okay, given that is the function y of x. Okay, when x is equal to 2 and when x is equal to negative 3. Okay, so we do here. Okay, so rate of change, okay, of y equal to delta y over delta x. Okay, again we know that it is y x plus delta x. That's y x, okay, and then x plus delta x minus x. Okay, so this one we can cancel out. So what left is yx plus delta x minus yx over delta x. Okay, so we have to find the yx. Okay, so given the function is, okay, the function yx equal to x2 plus 3x, right? Okay, this one. So now we are going to find y x plus delta x. Okay, so just replace this one into, we have to replace this one into x here and x here. Okay, so 2 is plus delta x, okay, then plus 3 x plus delta x. Okay, so here 2x 2 4x x plus 2 plus 3x 38x. Okay, so just plug in the value into this one, into this one. Okay, so we just straight put in. Okay, so 2x2 x2 plus 4x theta x plus 3x plus 38x, okay, and minus yx, which is minus 2x2 plus 3x, okay, and then over theta x, so we can cancel out certain number, which is 3x here, 3x here, s2 here, and 2s2 here. Okay, then we can factorize the delta x outside. So this will be 4x plus 2 delta x. Okay, and then so this is delta x, not 38. Okay, confused. Okay, so plus 2x and then plus 2 delta x plus 3. Okay, so can cancel out. Okay, so the rate of change, okay, rate of change of y, okay, is equal to limit, since we use delta x tend to 0, okay, the 12x plus 2 delta x, okay, plus 3. Okay, so this one will be 0. Okay, since it is 0, so this one is 0. So what left here is 4x plus 3. Okay, so when x is equal to 2, okay, rate of change of y, is where y prime is equal to 4. Replace x with 2, okay, 2 plus 3, so we get 11. Then when x is negative 3, my prime rate of change of y, okay, we convert the x into negative 3 plus 3, so we have negative 12 is equal to negative 9. To negative 9. Okay, so that's it. Okay, we will continue next. Okay, so we will continue next. Okay. Thank you so much and Assalamualaikum.